All right, hello. We're back with another project here. We have an enterprise network here. We have DHCP, LACP, LDD, kernel, VLAN routing, much more ACLs running in the full-time network. And I'm going to just basically explain about how this works. I actually have the code right here. Yeah. So from the bottom right here, we have four VLANs. 92 starting with 192.168.0.0 and dot one, dot two, dot three. I mean subnets. Right? We have four of these VLANs and subnets, and essentially for the creation of these VLANs, we are going to be putting them there in different respective interfaces, right? I basically did it right here. We created a VLAN, right? Well, host name first, changing the host name to it. Created a VLAN, created I put these computers into their own created a trunk port to the layer 3 switch for it as well, right? And essentially, for every single of these switches, these four switches, we're just copying it and replacing the number of the VLANs or this is very simplified. All right, one thing I should say, this is very simplified. Okay, very simplified. Like you can expand this as much as you really want to, right? Uh, but I just kept it simple to kind of like so more of all of these and all of these like services running at once and compact. This you can explain this could be like one root of like a part of like a bigger network like right. And this you can probably copy this whole same design from many different. So that's done right. And the molarity switches are putting getting the IP addresses for the uh, VLANs and most importantly the command IP routing so that we can actually do the right. So for instance, I have the well can do it the request real successful, right? I can go and get the IP address on this 1.11, right? We can go back to 0, right? And go command prompt, the ping command of dot 11. 192.168.1.11, right? First one's gonna fail because of ARP because it doesn't know the IP address of this, and then the rest is successful, right? And I could do that for every single one of them, including even the last VC. First one's gonna fail because of ARP, IP address, and so generally this is supposed to be a more redundant network. So if one of these switches is going down, one down, they could connect to this one, and if this router goes down, it's the one. And this what this does is that essentially it allows it so you can still talk to the to access the so you at least have two fail points because redundancy in a nutshell usually is like two devices of like the same caliber thing. So like you would have two switches of that. If one of them were just someone out of nowhere just fell, you still have a backup. And if you don't have any, then that you have a bigger problem on your hand. But generally you would have like two of those like the same device type. So two layer 3 switches. So one goes down, you still have traffic going to the other one, right? One can take over right off the bat. Same thing for a DHCP. You would have one failover, and stuff. On DHCP, talking about routers, you would have another router so you can. And for the ISP, same thing. ISP probably would have two. You would have two ISPs. One so if one just has like a whole service outage, you can talk to the internet with stuff like that. So and the layer 3 switches again putting the IP addresses for all of them, right? Even the VLANs and stuff like that. And same thing for this side. I will notice that I did do a dot two for certain VLANs like 30 and 40 for the first layer 3, and the other one is uh dot 1, and replace for the other ones. The real reason why is because I actually have correctly um I know ST. I probably didn't do it. Essentially, I'm like dividing the priority. So like I'm having one layer 3 cover like like 10 or 20, another one cover 30 or 40, but it still will cover all of them. Is that priority wise, right? Um, we have LACP with LACP report channel of these four um links here. And so if you don't know what LCP is, lower aggregation report channel. Cortana is the thing. Saying this wrong, but essentially it combines multiple of these physical links into it's link aggregation protocol. Sorry, uh, it essentially combines all of these essentially combines all these physical links and does it for redundancy. Right, it's very simple to switch to set it up. So, we recently create an interface. Well, we'll create a port channel right under the interface. We do it no switch port so we can actually enable routing, right? No switch port in a nutshell. Essentially, so switches are layer 2, right? They deal with MAC addresses and stuff. Layer D switches have the layer 2 capability to stuff, like routing. That's hence why they're called multi-layer switches, because they're sometimes just called layer switches. They do routing. They're the main reason why you're able to do it in the first place, right? Unless you don't have that and you're using just a regular standard router, layer 2 device, and just router, then yeah. In that case, then that would work. More multi-layer switches just have both of them combined. If you saw my previous video about router on it, um and router on a stick and just multi-layer switch in general, like I'm basically explaining that it's just multi-layer switch is just two devices, right? So no switch port would essentially switches by default these switches will have these ports will have being like layer 2 interface, the layer 2 in a sense where it'll mainly just do switching, right? But no switch port will turn that interface, right? Because that capability is only done a layer 3 switches to a router, so he does the routing, right? That's why we're able to do the IP address. If you were to try to put an IP address to this without doing the no switch port, it won't work. It'll just say decline because it's not a router port. So basically, we gave it an IP address for both of these sides, right? And not one on one, and not one on two, right? The switch port and the file command is channel is for the interfaces that we have. Put it in a range and changing it to no switch port, and then giving it a channel group of a channel group of one mode and active, and we do it on both sides, and uh, then port channel is active, right? So that's that part. OSPF is running here. If you don't know, dynamic routing protocol automatically learns its uh, dynamically about you have to configure size. All you need to trigger like what advertise. Here we're advertising 192.168.0.0. This is a broad, summarized route, right? Essentially, this is encompassing both 0, 1, 2, and 3, but it can encompass even future VLANs or subnets 4, 5, 6, all the way up to 255. Right. I also have the specific ones of these ones 10.2.2. So this network here. Remember, this we're starting from this switch on. If you see my cursor, this switch right here. Right. We see this layer 3 switch right here on the left. Because read from left to right. This switch right here. Um, sorry for this is the config for this one. It has this connection over up to here on this router, first router, 10.2, not 2. So we're advertising this 10.7.7, which is the other one connected to this. It's at 10.1.1, which is also is connection to the other layer, right? And then we also do have IP addresses ones for the routers, the links to the routers, right? Same thing on the other side, but this one we have dot three network right here, or is this dot three element, and then we have a dot eight element with both these routers, and dot one obviously to connect to the other one, right? We're basically advertising everything the links that are all connected to each other, right? And then for the router config, we just have all these interfaces with their own IP address for their respective subnets. So router zero, right here, has interface connected to um the layer three switch, both of them actually, and then to the router and to the ISP, right? And we're advertising all of them. Now you can make this broad. I did make it here, but essentially, every single one of them connected to each, right? Um, Same thing for the other router. And for the ISP, only just need to configure two interfaces and also advertise these. So they can talk to each other. If I were to show F and E, because you can see that it knows has both of them as neighbors. This one, it has all three. So that's what I mean by like that's what I mean by connection. DHCP, this right here. DHCP is pretty simple. You're basically creating a pool for these VLANs, right? And uh, I'm create a exclude address. So it's basically removes like a range of addresses that it would give out. Perfect for if you're trying to give it to a server, right? And any really any device uh that actually will change. Because remember, DHCP gives out leases, right? DHCP gives out leases where they will expire after a certain amount of time, right? If you want to give a static IP, usually ask for devices that you need that are essential that can't change. Typically servers in a sense, right? Either we're getting a network, so basically a network over. So this one for this case is dot zero zero for this whole network, and default router, which is dot one, which is the actual router, right? Or the gateway in this sense, right? And we do it for all of these four pools. And for the final part, this is like the most important part. In order for these clients and these VLANs to actually get a DHCP uh, request or be able to get an IP address in the first place, they need to have a helper address on their VLAN, on their VLAN, interface VLAN. And this is done on the layer 2 switch. Every single one of them needs it because if you don't have it, it's not gonna be able to actually find the. This essentially allows the layer 3 switch to forward that request to the actual router because it actually has a specific address. And we do that for all of them. LADP is running on all of them as well. And ACLs, access control list, basically permitting denying IP addresses to communicate. In this ACL right here, 3.0, let's say I want to, I did this in the perspective of, let's say, in your home network, if you guys don't have, essentially, like, if you want to make your one of the ways you can secure your networks is with having IoT, right? So essentially, the Internet of Things. Essentially, this could be light bulbs, smart devices, and stuff like that. This is the stuff that usually can communicate in the internet, right? But I have, in a sense, also can be one of the ways of getting attacked because and the main reason is because sometimes they might not be very secured. This essentially, I did this access list in the sense of the way where all these other VLANs, right, dot zero, volt, VLAN 10, 20, and 30, can talk to the 40, but they can't talk to it. But 40 can't talk to them. So in a sense, that like, let's say this device gets hacked, right? It cannot communicate to all. It only can communicate to only the devices on its network. but it cannot communicate to other devices. And this would be like very critical for like mission critical like uh devices, servers, and backend stuff that like if it were to go down, it would be catastrophic for a business, right? This is essentially what I did here. I used the IoT version of it because if you guys don't know, if you have a smart TV, it does listen to you. If the microphone, it does listen to you. Um, so yeah, this is essentially is what we're doing. So essentially, for ending this, the NIT IP of 3.0, and it on the mask, right? Any device. So, well, I'm gonna explain this, right? Any device in this subnet cannot talk to this specified uh social device subnet. So it cannot talk to any device in dot zero, dot one, dot two. That's the basic way to explain it. But this basically deny IP source destination. This is the this is the source mask and this is the destination. And oh, by the way, this is a wild card. This is not a actual something mask. Wild card mask, right? Permit IP any. So this is allowing any other IP after this. And then remember, ACLs they read in like they read from top to bottom, right? So whatever priority that you put first on top is gonna be issued out first, right? But after that, like permit IP any, this will still be in effect. This won't replace this. This rule right here will replace this, right? And we do. I can show you this, right? So 3.12, right? If I were just to go and ping, I'm trying to. That's the IP. Dot 12, right? PC0, right? If I were to just go and ping this one, it will fail. Uh, I would assume it was working. Did I actually? It will. I don't know if I actually saved it. This is why right memory is very important because this actually does work in theory. No, I didn't. Yeah. So see, this is I'm actually catching my own mistake. I didn't actually apply it. I just created the list. So if I need to go and do this really quickly, and right. Okay. Now if I do it again, it's still working. That's weird. I didn't even get applied. Did not get applied. Uh, did it get applied? We should be seeing it, but I might have to pause it real quick just so I can actually just show you. Because this is actually it was not applied already. I forgot to actually save the config. Alright, I'm back. I tried doing in and out anywhere. Oh well, in theory, this was what was supposed to happen. It's supposed to actually go to paint. It keeps allowing a but for whatever reason. I actually don't know why. Because maybe someone else could actually give a comment on why it's not applying. But essentially, this is in theory what it's supposed to do, and that's about it for the whole. That's essentially it for the whole. Right. Actually, that's an or in and about the whole project. Uh, right. Have a good day. Yeah.